Good day guys, and let's begin our second sample problem on the principle of dimensional homogeneity. Of course, the question states the velocity of a streamline flow in a small unit tube depends on what? The radius of the tube, the density, and what? The coefficient of viscosity of the liquid. Use dimensional analysis to obtain an expression for the velocity. Of course, let's go to these questions. They say that what? The velocity of a streamline flow depends on what? So let's combine the formula one time. Depends on three parameters. Of course, to say number one, the radius of what? The tube, density, and the last but not the least, in this case, the last, we have coefficient of viscosity. So this is the radius of the tube, density of the tube, and what? Coefficient of viscosity of the liquid. Of course, let's call this equation 1. Let's introduce a constant. So we have V as what? K, rho, rho. Of course, this is the coefficient of viscosity. So therefore, let's, of course, rho is in terms of L. Density is in terms of what? M, -3. We have coefficient of viscosity as what? M, L -1, T -1. This is the dimension of this. Of course, straight to the question, we are going to assign the alphabet to each of those quantities: radius x, density y, and coefficient of viscosity z. The next step is what? Let's call this equation 2. Of course, the next step is to express this in terms of what? The dimensional, which is fundamental unit. Velocity, of course, we have m0, l, t, -1. This is k. We have radius in terms is l, which is what we have here. X, density is m, l -3. So in terms is y. Of course, the last we have m, l -1, t -1. This is z. The next step is to open this bracket. So we're having a case where we have k. So let's go with m first. So we have for m, so we m y raised to power m raised to power y. So we have the first m, term of m, and y m raised to power z. So we have plus z. We explained that in our video. So please, if you don't understand these concepts, go back to the first video on dimensional, which is sample problem 1. So the next step we have L. We're looking at L raised to power x, L -3y, and L -z. The last, which is we're looking at time t -z. So this is the concept. Of course, our steps next to consider each of what? The fundamental quantities. So we are considering m and m, l and l, and t and t. So let's do that in the other part of the board. Of course, for m, so let's consider m. We have m raised to power 0 equals to what? M y plus z, which is in turn, we have 0 is equals to what? Y plus z, which is in turn, this becomes y is equals to -z. The next we're considering for L. So we have L, of course, this is L raised to power 1. So this is L1 raised to power 1 is, we have L x -3y -z. So this becomes 1 is equals to what? X -3y -z. So therefore, since we know that y is equals to -z, it becomes that 1 is equals to x -3 -z. -3 no other than -z becomes 3z -z. So this becomes 1 is equals to x plus 2z. So let's leave that one, please. Take note of this. So the next part, let's consider for t. So we have for t, we have t -1 is equals to what? T -z. So this, we cancel this and we have z is equals to 1. we can substitute the value of z into here. But before we do that, we say that y is equals to negative z. So therefore, if z is equals to 1, y is equals to negative z, which is in turn negative 1. And of course, let's find the value of x. So making x separate formula from here, I have x is equals to 1 negative 2z, which is in turn we have 1 1 negative 2 into negative 1, because we say z is negative 1. Sorry, we say z is 1, right? So this becomes 2 into 1, which is 1 minus 2, which is minus 1. So therefore, x is equals to negative 1, y is equals to negative 1, z is equals to what? 1. So therefore, we are going to substitute these values into what we have here as our equation 2. So we are going to substitute that value into here. So let's wipe this off. So initially, we had that the velocity is equal to k, radius x, density y, and the coefficient of viscosity z. So we're going to substitute that value into here. So we have v is equal to what? K. Of course, we have radius, which is negative 1, density, negative 1, and what? Coefficient of viscosity, 1. So therefore, this becomes k, this over what? Arrow density. So therefore, this is the value of what? The velocity of a streamline flow. Of course, the concept is very, very easy.